Okay, so for number 3, we're trying to find the acceleration, the acceleration of the ball at the constant, at the instant, also including its direction, so whether it's going up or whether it's going down, the acceleration. So what I did to solve this problem was use the equation that says that the sum of all the forces is equal to, so now I put what the sum of all the forces is, like what are all of the forces acting on this ball. So what's acting on it is negative 3.6 newtons plus 4.3 newtons. And this shows you that this force is the weight of the ball. So the weight is always going down. And this is the buoyancy. So the buoyancy is positive because it's going up. So because buoyancy is floating, so that's why this is positive and this is negative. So if we solve this, we'll see that the sum of all the forces is equal to 0.7 newtons. So this is the sum of all the forces, but we want to find the acceleration. So we know that acceleration is equal to F divided by m. So the acceleration will be 0.7 divided by 3.6, which is the mass or the weight that we saw in the question. So we know that the acceleration is approximately 0.95. So that's the acceleration. So let's go back to the not newtons, meters per second squared. So we know that the answer is 0.59 upward because we got a positive number. If this would have been a negative number, then we know that the force is downwards, but it's positive, so it's upwards. Up.